Okay, so we're going to be covering breadth first search, or BFS as it's most commonly called. BFS is one of the most fundamental graph traversal algorithms, and what it does is that it searches through all of the vertices of a graph. So given an input graph, G, and assuming that the graph is connected, otherwise we won't be able to search all the vertices, and a starting node, it searches through all the nodes. So it works by going layer by layer, essentially. So just like a high level overview. So first, we're going to start at our source node, which we'll visit. We'll visit all the source nodes' neighbors. And then for all of those neighbors, those neighbors also have neighbors. And so the unvisited neighbors of our neighbors, we'll visit all of those. And then we basically continue. So, just so you guys can see how that kind of works out, we'll start, at our source node, we'll visit that. And then that source node has, let's say, these three neighbors, right? So then we'll visit those. Boom, boom, boom. And then for each of those neighbors, we go through them and see if they have neighbors. This one doesn't have any neighbors. This one has one neighbor. And this one has two neighbors. So then we'll visit all of the neighbors. And then, we'll keep going. Assuming the graph continues on, we'll keep going until we've searched through all of the nodes. So it's important to understand what data structures BFS uses. So to keep track of the neighbors, or to keep track of the nodes that we're going to visit, we'll use a queue. And to keep track of the nodes that we have visited, we'll use a set. Okay? So just a brief overview of some pseudocode. So first, we'll create or initialize the queues and the sets, and then we'll add the start node to the queue. And then we'll mark the start as visited. And while the queue is not empty, we dequeue the node that's at the top. So queue is first in, first out, right? So it's like a line. So we'll dequeue the node that's at the top of the queue. We'll process it, which could be printing, could be doing whatever we want to it, but while we're searching, we're doing something with the nodes, assuming we are doing something. And then the node that we dequeue, we look at all of its neighbors. If we haven't visited a neighbor, then we mark that neighbor as visited, and we enqueue that neighbor. So we add it to the queue of all the nodes that we have to visit. If it is visited, then it doesn't matter. We've already searched it. And this keeps on going until we visited all the nodes, or until the queue is empty. If the queue is empty, it means that all the nodes have been marked as visited, and there's nothing left to search. So I guess we can analyze the time complexity of this algorithm. So initializing queues and sets are constant, and then we know that set or queue operations, since we're concerned with dequeuing and inqueuing, we know from class that those operations are constant time, right? So since each vertex is enqueued and dequeued once, and like we said, those are both constant time operations, it means that to search all the vertices, we're doing O of V time, okay? And then each edge is also checked once, so we're doing O of V time to check the edges. That means that the total time complexity of the BFS algorithm is O of V plus E. So yeah, this was just a brief overview of breadth first search. Like I said, it's one of the most fundamental algorithms in computer science, and it's a must know. So thank you.